Guys, this is the 2011 Junior Search Fire Level Section A short questions. Let's get started. First one is always written answers, so identify the 4 different types of triangle. Start off with the easy ones. This guy here is going to be your right angle triangle. And strike off as you go. Sometimes they can look a little bit odd, but to me this one here is our equilateral. These two sides look the same. Now if they look too similar and you're not sure, measure or grab the compass and just check that that side is equal to that side, but that's what I think it is. So let's ask this. And finally scaling. Next, complete the elevation of the given sign in its rotated position as shown by the broken line in plan. So take all detail down to the original position, rotate it around to the new position and bring it back up and draw it in the elevation. I'm going to just label first off. Label point 1, point 2, 3, 4, 5, and then point 6 is here. The pivot line or hinge line down through the centre from 2 to 6 remains exactly where it is. Point 1 rotates around to a new position, and 4 and 6 are here, and they rotate around to their new position here. So I'm going to need to bring down point 3. I'll probably need to bring down, actually I don't, if I have 2 and 3 I can just line that part, but that's the only point. 1 is done, 4 and 6 are done, so it's just point 3 down, rotate back up, and then we'll work on the elevation. Now, from the new position, which is the broken line, we will just project everything back up. There's point 1, there's point 3, and there's 4 and 6. When you rotate something, heights don't change. So as this object rotated, first off, the position of 2 and 6 can't change because that's on the pivot, on the center line. Point 1, as it rotates around, the height doesn't change, so it remains a constant height across to here. That's the new point 1. Point 4 and 5, as they rotate, come straight across to here at 4, across to here for 6, and then finally point 3, as it rotates around, just comes straight across as well. So just extend on that line a little. So I have 2 down to 3, I have 2 down to 1. I'm out as far as the new number 4 and down to number 5 there. So there's the new. You're not asked to shade it, I'm just doing this for the video so that it's clearer to see at home. That's the rotated position of the object. Question 3 is a perspective. Now we have to take a look here at what's actually shown to us. The graphic will always tell us a lot of information in a question like this. The back or the right portion of the building is complete. The ridge all the way to the top is complete, which is strange. They'll often leave out a portion of that here and you'll have to push through with your projection. And it goes along the ground, it gives us the finishing point here. What do we need to do? Well, we'll just start joining back to our vanishing points and see what's happening. To establish the centre of this, we'll say what would be probably a rectangular face here, it's established using your two diagonals. That gets you the centre of the face, which then we can project back to a vanishing point. The equal, we don't need to bisect with a compass or anything like that, because our diagonals gets us our centre point. To start, I'm just going to take the bottom line and project light. I don't know how far that goes just yet, so I'll do that in just a minute. To find the back point, it's the same width as the building. It's going to be based on this base point here, projected the opposite way. So I'll join what would be the front corner of the building back to cross. So that gets me this bottom area here. I don't know yet how high it goes. I need to figure out this front face first off. Chopping in my diagonals. Them diagonals, as I said, will get me the centre of the face. So I can join the centre of the face back to VP1, first vanishing point. I should label that VP2. Centre of the face to the vanishing point, and that's going to be a hard edge there. This, along the right side, this projection goes back to VP2. And I'm going to need my two vertical lines. So line up with the vertical edge. Always take another look, make sure that you have hit all of the important detail, make sure that there's no other areas, as I said in some previous videos, if there's doorways or anything, that there's one, if there was a doorway there, that there might be one line hiding, vanishing back towards a different direction. In this case here, just take a quick look, this is the line that I'd be expecting people to miss, but I think there's very little to do in this one. That's it, all complete for me. That's the first three done. On to question 4. Freehand sketching. The elevation and in view of a fireplace are shown on the square grid. Make a pictorial sketch of the fireplace, colour or shade. Now, there's no curves, there's nothing very difficult here in this one. I will be taking a look, of course, if there's hidden detail, and at the top of this fireplace is going to overshoot. It's overhanging left and right by a box, and at the front by a box. I'll start off with the base. Just count up your boxes and apply them here to the 30-degree isometric dot grid. you have to really watch out for your areas here, what's overhanging and what's not. So I like to, even though I know that I can't see the back of the object and I won't be able to see the back of this initial step up here, I'll still sketch it in very light because it just helps me to structure the whole drawing. I know that if I go to the back corner, I can step out a box. So from the back corner, I should be stepping out one and up one. And that's going to give me, I'd say the mantle, the top mantle, it's going to give me the finishing point for that. The heart area of this fireplace is going to be cut back in, so that's hollow right through to the back on this little diagram. So that means it goes back in by 2 boxes. And it'll have to stand up and across, and the top cannot be seen because of the mantle. We can't see the top of the opening. Finally, we're adding a little bit of shade to this. Again, you have to assume that there's a light direction maybe. So I'm going to just assume that the light is going to come from this direction here. And the reason for that is it gives you an opportunity to just make some faces darker and leave some faces much brighter or lighter shade. This face, and this face are all going to be quite bright. There'll be a small shadow cast maybe on this one. If the light direction was coming from a high angle, that overhang might cast a small shadow. There'd be a fairly significant shadow cast on this face here. But it's not going to be a complete. Some sunlight will get to it. There'll be the top and side there will all be bright, bright, bright. This could be bright, but if it's coming from this back direction here, it's going to be, there'll be quite a dark area there where all of these are overshadowing. Maybe something like that, and that might also make its way onto the ground. As always, go a little bit heavier in the part of the object that sits on the ground. And I think that's perfectly sufficient there. What's done, there's no need really to be adding much more than that in. Next, conversion of areas. So the figure shows the outline of a car window ABCD. Draw a triangular window equal in area to the quadrilateral window, having a vertex of the triangle at B. Meaning we need to just take the area of what we're given and change it into a triangle of an equal area. There's a simple enough little construction to this one, and it's a fairly consistent question when it does come up. The only little thing that might change is that instead of giving you a vertex at B, they might say a vertex at C. So Basically, we're going to need a base along AD and a vertex up at B. Now, obviously, ADB satisfies some of that because we have our base and we have our proper vertex, but we need this area here of the second triangle. So if I split it right now into BD, that's a small triangle, and there's a second one here. That's not quite going to get me there, but it'll get me a step along the way. So the first thing I'll do is just split this up into that shape there. So right now I have a base along AD, and I have the point here at B as well, but I need to take this area here and I need to add it on. Okay, so add it on to this ABD triangle. And how we do that is by going parallel. I'll explain why in a second now. We just go parallel to that line that I just drew. And I'll extend out then along AD. And now I've actually answered the question once I just joined the dots. I'll explain why just a sec. Again, there is no need to add colour, I'm just doing it to help me to explain what's happening here. The new triangle and the solution to the question is here. So that triangle in red there is equal in area to the original quadrilateral, and there's a reason for that. Here's the reason. If I just drop down just to help me illustrate this as a separate, now this isn't required as part of the question by the way, if I drop down two parallel lines, any triangle that goes from A to B as a baseline, any triangle that touches up here on the line with a point C is going to have the same area. So any triangle at all, if I use that as point C, or if I go over here for point C, or if I go all the way over here for point C, they all have the same area because it's half the base, which is consistent, and it's perpendicular height, which is consistent as well. I've just used that here by creating a parallel base and height line. So I can take that exact theory right there, and I could skew off the two lines, and I can drop a base of, in this case it was the green base here, BD, and I can say that's my baseline, and then point C, so BDC is what I broke up first off. Point C is about here someplace. Now the proportions aren't the same, but if I take BD as my baseline, I can move point C anywhere at all, which means I can move it way down here if I extend this on until it's straight across. That triangle right there, B, C and D, has to be the same area as the original BCD. So by using parallel base and height lines, it allows us to transform this triangle into this triangle. So when we transform BCD into this guy right here, B, call that C1D, well, it's side by side, we've added it onto the original triangle. So that's how we converted them areas, using parallel lines for base and height. Question 6. A gate with 7 panels of equal width is shown. Complete the elevation of the gate, showing clearly how to determine the width of the panels. Now I would be fairly sure that we can't just get an easy few marks here by dropping it down, and it's a multiple of 7, so this is in at approximately 85. And even if the numbers did work out, I'd be highly doubtful that they can just hand us the marks for just marking, let's just say 7 intervals of 20 millimeters if this was given as 140. Instead, we're working on equal division of a line. So I'll my 3-step method here. Run off a line at any random angle, any length, any angle. Set your compass and step off 7 equal dimensions along that line. number those. Now that's going to give me 1 panel, 2 panels, 3, 4, 5, 6, 7 panels when it's applied onto the original gate down here. Using my sliding set squares, join point 7 to the end of the gate and go parallel from all other points. And again, I'll just use sliding set squares. There is no need really to be sticking on pages and using T-square for this. I'll use sliding set squares and reference off one of the vertical lines. And from all of the points where my parallel lines hit, I'll just draw a vertical to show the division of these panels. So 1, 2, 3, 4, 5, 6, 7 equal panels drawn. That's our first 6 questions done. On to number 7. Number 7 here. The figure shows a logo for a music shop. The logo is not complete. Complete the logo by constructing an image of the figure ABC, so that's this original music note, under central symmetry in the point P. So symmetry through a point means every part of the original image goes from its position through the point and out the other side. And I'm also just going to take this point here where B hits the circle. Take my compass and I'll mirror those guys through the point. So starting it off, maybe if you feel more comfortable, you should do these one point at a time. I'm just going to drop them all at the same time just to make it a bit faster. Point C. Is here. Point B is next. And this external point here is going to be next, but I'm actually not going to project that. I don't need to project that. I'll project the center. I take the radius of this little circle here and draw it. And I knew that would probably happen. When you're drawing such small detail, it's very hard to keep that compass set in place. I'm going to just flick my page around for this. Now if you do happen to have one, circles template would be really handy for circles that small. Very, very useful. As you'll just, if you were using one, you just keep working along until you'd find the perfect one that matches up. Have a sharp pencil. Maybe you'd even go a size up on it if your pencil wasn't quite as sharp, and then just transfer it across and draw it through, which will give you a very clean solution and hopefully no slips, unlike what happened to me there. Just to be able to size this up here, point 1, the point where B joins down, where is it exactly? Point 1 would be on this side here, so it's looking like it's right there. Point 1. To join the dots then, C is the far down, and then this is B, so C onto B and B up to 1, and then they've called that point A. think that's that one complete. There, sorry, I was going a little bit off out of shot there in that one. Next up is freehand again. So in the space provided, draw a freehand pictorial sketch of the whistle, colour or shade the sketch. Now, but I'm going to start off with here like I always would, if it's a round object particularly. You draw that as a full circular area and then add this on after. Similarly with the front, I'll ignore the fact that it's tapered in, and I'll just draw it as a full created in area first off. Now, what is this looking like? It's a square based here to house the circle, and the height and width being the same, of course, and the depth isn't quite as much. So I'll get started. You can draw this facing any way you want. I'm going to draw with the mouth part of the whistle facing out towards me. Now, I certainly wouldn't be encouraging anyone to go straight into drawing the actual product itself. I'll be starting off by drawing this crating here, which will help to build up. Well, look, we can actually start off with nice, neat squares and easy to work with. Let's say this first square here, the second one's probably a little bit larger, so if I take the proportions of the first one and just add a little bit more on, and then I'm going to go back in an isometric here. As I said, the height and length of this first area is a little bit larger than the width of it, so that length is probably like here. So I'll go a little bit less than that. Take the original angle. And as I also said, I'm going to ignore the tapers in the front of it for now. I'll just leave it all square there. Now it's time to start fitting in the round object now. Pick the center of each face that it's going to touch. I'll work on the back of it maybe after, but I do know that the back of it will have to hit some similar points like here and here. Then down towards the front, I'll go full width for now, down to the ground. Next, I'm going to taper it in, so the width, it just cuts in a little bit at both sides here for the front. And time to work it in. It seems like it goes straight out for a small portion and then starts tapering, so I'm going to have to change my angles. Straight out first, and then taper in. Same here, so I'll take the original angle, straight out first, and then taper it in. And what I'd avoid, so it maintains a constant width from the original top position, constant width, so pick a width, and then it seems to just fill it off down into the shape. It's hollow inside, it's kind of hard for me to show here. And it has the hole up top, so where is that? That's probably just on the back side of this split that I've drawn here. So wherever that split be, that'll be about there. And there it is. There's a lot of hidden details shown on the elevation and plan. What should I be able to see inside here? I'd probably just be able to see something like that. Might be able to see a little bit of the curvature of the base here as well. and it's an object with thickness, so there we go. That's my efforts at it. Might be able to see a little bit of the base of the whistle here. As I said before, the part that's often missed is the colour or shade. So just a little bit of shading maybe. Again, give yourself a light direction coming out this way and project it down onto the ground as you see fit. We won't be doing a huge amount of shading here, but at the same time we'll add, first off, the shadow of the object as it sits on the ground there. I'd like to add that. I think it'll make it look good. Smudge that in a little bit, and then just maybe a little bit of a shade off the side of the object here, or the back of the object, because that's all in shadow or in darkness, so it should all be shown pretty dark. Just to show that this guy here probably have a little bit of shade towards the back and very little towards the front. The inside of the object is going to be dark. It's not going to be getting any light there. Something like that will be perfect. It would suffice perfectly and will get you full marks. Next, nice easy one. That one would have taken a while, but I to do so. A nice fast one here. 4 Cad Commands. Or sorry, I need 3 Cad Commands. There's a good few. There's 1, 2, 3, 4 shown. So I need 3. First off, this is to extend. So when you have a line segment already drawn, you want to bring it on to finish at a second area, you can just extend. On SolidWorks, part of the same tool is trim. So to take off a line segment. To bring it from 2D to 3D is to extrude. And then if it was a straight cut, it would be a chamfer, and when it's a round, it's a fillet. There's 9 questions done. Number 10. Now these ones, it's just a little bit of spatial awareness here now, I suppose, and being able to imagine and especially being able to see what's behind the object, to realise that 1, 2, 3, 4, 5, 6, 7. There's 7 bricks on the second row. There has to be 7 under them to support them and hold them up. Now, it's up to yourself how you want to go about this. If it's me, start on the ground and go row by row and just write down your numbers as you go. So on the ground I must have 3, 6, 9, 12, 13, 14. On the second row, 2, 4, 6 and 1 and 7. On the third row is just a 1. And on the fourth row, 2. And go back and check. These are a fast question, but you don't want to make a silly little mistake with it. That's 24 in total. Up next is angles. So this time, what are we dealing with? Write down the measure of the angles A, B, C. Angle A up top. It's a little bit open-ended here. It should probably give us a little bit more information. Now I'm looking at this saying, because there's a center line shown, I'm guessing it must be symmetrical. Just check it very quickly just to be sure. And the width out to the left is the exact same as the width out to the right, and the width out to this point here in the drawing looks to be the very same again. Yeah, so it is symmetrical. Just that center line, that's all that suggested it might be symmetrical. Taking that into account, I'm going to come back to A. I'll just work my way up along first of all. this angle here is 90, this angle is 34, so the remaining angle has to sum up to 180. Okay, so that would mean that it's 180 minus 90 and again minus 34. So 180 is the three angles in the triangle together. I'd like to find just this angle here for now. Minus 90 minus 34 will leave you with an angle of 56 degrees. 556 and 60 will again angle, all three angles here have to add to 180. So 56, so it's 180 this time, minus, maybe you can do these in your head, minus 60 minus 56, and you are left with an angle C of 64 degrees. So that's C, 64 degrees. Next, if this is symmetrical, and I've just checked it with the compass to make sure it is, that would mean that if this is 34, this is also 34. The overall outer triangle has to be 180 again. And if it's 34 on the left and 34 on the right, the remaining angle at A has to be the balance, because first, second and third angle all together have to equal 180. So this time it's going to be 112 degrees, and that is angle A, 112. Finally, angle B. We could go about this, we could just say, right, we need to find out this guy here. That's the way I'm going to go about it. We'll find out what this guy up here is. So I'm going to work with this triangle here, the one that contains C and this. But if that's a 90, then this has to be 90 as well. And again, the three angles have to be 180, so it's 180. And it's going to be minus 90. And it's going to be minus 64. So 90, 180 minus 90 is 90, minus 64 is 26 degrees. That angle right there, 26 degrees. We already found out angle A was 112, so the total angle A is 112. 112 minus 26 minus 26 to 26, so I can just drop them both down, or I could have put down 52. But all in all, I'll be left with 60. So this remaining angle in here, 60. What am I looking at then? 60, 60, 60, because it has to be equilateral, all three angles the same. So 60 plus 60, this has to be a 60 to give us the 180 total. Some people will just get these. There'll be no maths at all written down there. Some people will write out the full set of sums that I have done as well. So it's up to how you do it. Ellipse and normal. Next. The figure shows the design of a remote controlled car, also shows a small graphic of the car and an aerial here. AB is the major axis, so from A to B, and the aerial is a normal to the ellipse at point P, standing off here. Normal too. Determine the focal points and draw the aerial. So the focal points of an ellipse are found by taking half the major and applying it from the top or bottom of the minor. That gets me F1, F2. If they told us to get them, they must be important. In this case, to establish a tangent or a normal, you'll join your focus through your point of contact. Extend through. The tangent would be found by bisecting this large angle, or this large angle here. That would give us the tangent. The normal would be found by bisecting this small angle, or this small angle here, which will give us that bisector. So I'm going to bisect that small external angle there. There's my bisector, and there's my aerial. Does it give a length? No, it doesn't, so it's just leave it run on as far as you want. As long as your construction is shown, you'll get your marks. That's question 12. Question 13. The figure shows the elevation and plan of a speaker for an audio system. A 3D graphic of the system is also shown. Project an auxiliary elevation of the speaker on the X1, Y1 line shown. Once again, we're on to sliding set squares with this. I'm not going to be using an adjustable here for something so small and simple. It did not give us a projection angle of 30 or 45 degrees, but it did give us the X1, Y1 line. So I'll set up my sliding set squares, and then I'll utilise the 90-degree corner on my set square here. I project everything from plan, every point. Don't know what it's going to look like yet. I'll just make all of my projections first of all. Now, some people might find it easier to just project like a main body of an object first, but I like to just do all my projections and have that done. Next up, I'd like to just take the three heights. There's three different heights used in this object, and with the height of this first step here, and I'll just apply them all on the same line. Here's the height of my first step, the height of the second part of the object, and the main height up to the top. So, as I said before, if you project from a plan, it becomes an elevation, and this elevation is the same height as this elevation. You know, elevations don't change. All that changed is our position of our viewpoint. So we moved around, but the object did not change height. I might just drop in the three height lines now, parallel to the ground, bring them up, and I'll keep this light for now because I don't know where they're going to be used yet. And assuming that we are standing here looking up at the object, I'm going to ignore the back of the object for now and just work on this left block and right block. I'm expecting that I'll be able to see most of each block. So I'll start off with this face here. So it goes up to the second height from that point, and then it's going to be from this point. Now, for the likes of this, I'd always set up my sliding set squares again. They're so small, these drawings are, it's going to look very untidy if we don't use sliding set squares and if you're offline. That's the first point. Then we have the second point on the face here. Don't make a mistake on the projections that you draw on. We have this third front part of the face here, which is the next projection along. And we can put a top on that part. So that's the left block done. Moving along to the front block. So the first height here, the lower block. So on the first height, I'm going to take 1, 2, and 3 projections as well. And the third one happens to line up with the first one, so I can't do anything with that really. It's already shown. That's the left block, right block, and now the main body. The main body of the object is going to project up to the tallest height, so starting with this front corner here, right up to the tallest position. Then going to this corner here, up to the tallest position, not forgetting that also does it go down to the ground. Well, it's not going to be shown as hidden detail. I was just about to put in hidden detail. This corner here next. And again, it's going to all become part of the same face, I suppose. We don't have to assume it's hidden detail there, do we? Probably not. It didn't say that they're all made of separate bodies. So if they were all separate bodies, I suppose we should have hidden detail going down and going down. I'm looking at this back edge here, it lines up with the front edge, so the front edge takes priority. We can put hidden detail behind it, just in case these are considered different bodies. So if there were 3 different parts of the speaker, they would have to be classed as a hidden detail on these lines because they're different bodies. So I'll just put it in. It only takes a few seconds to do. That's the drawing finished. On to our second last one on the paper. This time, the figure shows the incomplete outline of a fishing weight. Also shows a 3D graphic of the weight. Complete the diagram of the weight by drawing 2 tangential lines. So we have our large circle to the front, small circle to the back, and 2 external tangents. So large front, small back, and external tangents going there. So the rule here, if the tangent is out, the radius goes in, T out or in. I'll take the radius of the small circle and subtract it from the big one. So I'm going to reduce both circles equally until one becomes a point and one just becomes smaller. So tangent outside, radius inside. I'll take the radius of the small guy. Now don't make the mistake, don't just redraw the small circle, subtract the small circle from the big one. So I've taken the radius of the small and subtracted it in from the big, and that is my new question that I'm going to solve. Now I might just drop this in with colour. We do not want to find liner to be slipping, so we are back to a very, very simple question now, but we just don't want to overcomplicate. We have this green circle that's given here on the left, and we have a point here on the right. So we've reduced it into a point, we've reduced it into the green, and then our method is join the point to the center, bisect the line, and draw our semicircle, which gives us a point of contact. So that's my first step here. So join the point to the center, and I better do colour here so that it stands out. Bisect that blue line. From that bisect position, and I'm still working on the green now. I'm not working on the larger question yet. From that bisect position, I'm going to just swing a portion of my semicircle, and what that gives me, this is not necessary by the way, what I'm putting in now, so I'll put it in light. That gives me a tangent from a point to the green circle, and from a point to the green circle. To bring it back to my full question, I need to, I'll just grab a different colour again here. To bring it back to my full question, I need to expand it back out. So I'm going to take the centre point through the point of contact and expand it out. So I'll go down first of all. Centre point through the point of contact and expand out. And using sliding set squares, I'll go the same angle, exact same angle on this guy. I'll do the same up top. Center point, through the point of contact, expand it back out, and parallel. That's everything. There's my point of contact on one tangent for both objects, and on the second tangent. Don't forget to draw the tangents. That's that question finished. Final question. As always, it's a bar chart, pie chart, or Cartesian coordinates. This time, 30 students were surveyed about the musical instrument that they play. The following are the results of the survey. Complete the bar chart to represent the information graphically. So accordion, 3 students. So accordion is already given as 3. Check out the units, make sure. Yes, that's 1, 2, 3. It's not going up in 2, 4, 6s or something like that. Or let's say if that was drums 6, it would mean the units were 2, 4, 6. That's the first little stumbling point that some people might get caught with on certain questions. I'm not going to label this y-axis of all the units just to have them, just to have it done. I'm also going to spare me that bringing in sliding set squares every single time. I'm going to just, what I'll do actually is I'll draw across all of the unit measurements so that I can go straight off in and I can go straight in and heavy in all of the particular areas when I want to just drop in the bars for each individual area. So I'll have my units applied across just like you would in graph paper, you know. It's much easier to have all the units there, and I'll start drawing in my bars now, and I know exactly how high to go with each one, and I can go straight in with the H pencil and go heavy. So tin whistle is next, so that's done anyway. Tin whistle is 5 students, so I'll take the angle, again set up your sliding set squares in line with the y-axis there for vertical. Tin whistle is 5 students, so take it up until you hit 5. Guitar is 8 students, and make sure that they're in the right order along the bottom of the graph as well. Drums, 6 students. Piano, 6 students. And finally, flute. Is this fiddle? Fiddle, 2 students. Bit of a slip there. Just add the top line onto each bar.